Hello students, welcome to Doubtnut. Our question is, two very long straight and insulated wire are kept at 90-degree angle from each other in XY plane as shown in the figure. These wires carry current of equal magnitude I whose direction as shown in the figure. We have to calculate the net magnetic field at point P at this point. So our options are mu naught I by pi d into z vector, option B 0, option C mu naught I by 2 pi d into x vector plus y vector, and option D minus mu naught I by 2 pi d into x vector plus y vector. So students, we know the formula for magnetic field due to infinite wire at point P, that is equals to mu naught upon 2 pi into I by x, where I is the current flowing in the wire and direction is downwards, means cross. This direction can be determined by the right hand thumb rule. So now we have to calculate the magnetic field at point B due to wire 1 and due to wire 2. So the magnetic field at point P is equals to magnetic field due to wire 1 plus due to wire 2. So if we calculate B net, that is equals to B due to 1 is mu naught upon 2 pi into current is I divided by D, and the direction is into the plane due to wire 1, so we can say minus k cap, plus magnetic field due to wire 2, this is mu naught divided by 2 pi into I by D, and the direction is outwards the plane, or we can say that plus ka k cap. So B net is equals to minus of mu naught divided by 2 pi into I by D plus mu naught upon 2 pi into I by D k vector. So we can clearly see that our B net comes out to be 0. So the net magnetic field at point P is 0 due to wire 1 and wire 2. So our correct option is option B 0. Thank you.
The question says that a current loop having two circular arcs joined by two radial lines is shown in the figure. It carries a current of 10 ampere. The magnetic field at a point O will be close to. So we have given an angle theta equals to 45 degree. Now we know formula to find out the magnetic field, that is equals to B will be equals to, for this type, now we have first radius is 3 cm and second radius is 2 cm. Now if this value is more, it means magnetic field will be small. So this radius is 3 and this radius is 5. So now we know magnetic field formula to find out at the center for this type of figure: mu naught divided upon 4 pi and theta 1 upon r1 minus 1 upon r2. And magnetic field, since so this value here r1 is value of r1 is 3 into 10 raised to power minus 2 meter, and we convert this value in meter by multiplying with 10 raised to power minus 2, and r2 is 5 into 10 raised to power minus 2 meter. So since this value is greater, it means magnetic field due to this length will be small. So due to this magnetic field will be inward, that is minus k cap, but due to this magnetic field is outward, hence magnetic field will be outward k cap. Now theta is 45 degree, that is pi upon 4, and current is, so we will use current. So formula to find out the magnetic field is use, so I will be there. Now using this formula, find out magnetic field. that will be equal to 4 pi into 10 raised to power minus 7, and theta is, value of theta is pi upon 4, so it will become mu naught is 4 pi into 10 raised to power minus 7, 4 pi is already there, into theta is pi upon 4, and current is 10 ampere. Put this value 3 into 10 raised to power minus 2 minus 1 upon 5 into 10 raised to power minus 2 kCal. Now on solving this value, so 4 pi upon cancel, and after solving this value we get value of magnetic field will be equal to pi upon 3 into 10 raised to power minus 5 Tesla. That will be nearly equal to 1.0 into 10 raised to power minus 5 Tesla. Hence option D is right. So option D is right.
Hello, we are given with the question, and the question says a coil having n turns is tightly in the form of spiral and is wounded in the form of spiral with inner and outer radii A and B respectively. When a current I passes through the coil, the magnetic field at the center is what? Right? So it is made into a spiral, right? Like this, right? Of n turns. So n is equal to n. Inner radius is A, outer radius is B. Right? So we can say this to be R and this to be capital R. Right? And the current is I. Right? So magnetic field at the center, what that would be equal to. So what we can say is that we can consider an element of, so this would be a spiral, right? Continuous spiral, correct? So what we can say is that at a distance R, right, we can consider a thickness element of dr, right? So the number of turns for that would be dn, which would be equal to n by b minus a into dr, right? In that section, it would be this much. So due to that, the magnetic field at the center would be equal to mu naught into dn into current, right? Mu naught ni by 2r, correct? So from here, dB would be equal to mu naught I by 2, right? So dn by r it is. So we can write instead of dn, n by b minus a into dr by r, correct? So since everything else is constant, we can take them out. Mu naught ni by 2 into b minus a, right? So from r equal to a to b, it is dr by r. So when we integrate this, this turns out to be log r. So log of b by a, it would be log of b minus log of a. So that is log of b by a. So the answer would be mu naught ni by 2 into b minus a into log of b by a, right? So our answer would be option mu naught ni by 2 into b minus a log b by a. That is option C, right? That is our answer. Thank you.
हेलो एवरीवन, क्वेश्चन है यहाँ पे हमारा इन नॉन प्लेनर लूप ऑफ कंडक्टिंग वायर कैरिंग ए करंट आई इज प्लेस एज शोन इन द फिगर ईच ऑफ द स्टेट सेक्शन ऑफ द लूप ऑफ लेंथ ऑफ 2a द मैग्नेटिक फील्ड ड्यू टू दिस लूप एट द पॉइंट ऑफ p a 0, a पॉइंट्स इन द डायरेक्शन. ओके, तो यहाँ पे देखो हमें मैग्नेटिक फील्ड फाइंड आउट करना है ड्यू टू दिस लूप एट द पॉइंट ऑफ a, 0, a. ओके, और यहाँ पे इसका डायरेक्शन भी बताना है मैग्नेटिक फील्ड का क्या होगा. तो ये लूप जो है देखो वो कैसा लूप है, नॉन प्लेनर लूप है. ओके, और करंट क्या कैरी कर रहा है, आई करंट कैरी कर रहा है. और यहाँ पे जो लेंथ है इसका स्ट्रेट सेक्शन के वो जो लेंथ है वो गिवन है हमें 2a, मतलब कि ये वाला लेंथ भी हमें 2a गिवन है और ये लेंथ भी 2a है और यहाँ पे ये लेंथ भी हमारा 2a है. ओके, तो यहाँ पे देखो इस पॉइंट पे हमें बताना है, यहाँ पे P पॉइंट का लोकेशन हमें दे रखा है A 0, a, मतलब कि x एक्सिस. तो यहाँ पे देखो ये x है और यहाँ पे ये z है और यहाँ पे ये मेरा y है. तो यहाँ पे P पॉइंट कहाँ लाई करेगा, P पॉइंट यहाँ पे देखो y का जो y यहाँ पे हमारा 0 है, ओके, तो कहीं यहीं पे लाई करेगा, यहाँ पे देखो y यहाँ पे है, ओके, तो ये P पॉइंट यहाँ कहीं लाई करेगा हमारा, ओके, x z पे भी ये है, तो यहाँ पे ये P पॉइंट है A0, A। तो इस P पॉइंट पे हमें मैग्नेटिक फील्ड फाइंड आउट करना है इस नॉन प्लेनर लूप की वजह से, ओके। तो यहाँ पे देखो इस लूप को हम मानते हैं कि ये दो लूप में डिवाइड हो रखा है, ओके, और इसमें करंट हमारा I फ्लो हो रहा है, मतलब कि इस डायरेक्शन में हमारी करंट की डायरेक्शन है ये ऐसे, ओके। तो यहाँ पे मैं इसको नाम दे देता हूँ, ये A हो गया, ये B हो गया, C D E F, ओके। तो यहाँ पे देखो हमारे दो लूप बन गए। फर्स्ट लूप है यहाँ पे हमारा, लूप फर्स्ट है A B C D, ओके। तो इसकी वजह से इस पॉइंट P पे मैग्नेटिक फील्ड देखो क्या होगा, मैग्नेटिक फील्ड क्या होगा यहाँ पे, मैग्नेटिक फील्ड, सो इस वाले लूप की वजह से देखो मैग्नेटिक फील्ड देखेंगे तो कैसे देखेंगे, यहाँ पे इस डायरेक्शन में है, तो देखो अगर मैं अपनी फिंगर्स को कर्ल करता हूं तो थंब किस डायरेक्शन में जा रहा है मेरा, पॉजिटिव वाई एक्सिस में, पॉजिटिव जेड डायरेक्शन में जा रहा है। तो इसका अगर मैं मैग्नीट्यूड की बात करूं इस लूप की वजह से, जो हमारा ये लूप है ए बी सी डी ए, तो यहाँ पे इसकी वजह से जो मैग्नेटिक फील्ड की डायरेक्शन है वो कहाँ है हमारी, के डायरेक्शन में, के कैप में। देखो इस वाले लूप को अगर हम कंसीडर करते हैं, इस पूरे लूप को, यहाँ पे ये वाला लूप जो है हमारा, ओके, इस वाले लूप में देखो करंट हमारा एंटी क्लॉकवाइज डायरेक्शन में, तो अपनी फिंगर्स को कर्ल करेंगे तो थंब कहाँ जा रहा है, जेड डायरेक्शन में, तो यहाँ पे डायरेक्शन क्या हो गई, के कैप, ओके। अब देखो सेकंड लूप कंसीडर करते हैं, सेकंड लूप क्या है, ए डी ई एफ, सेकंड लूप है यहाँ पे हमारा ए डी ई एफ ए, ओके। तो इस वाले लूप की वजह से अगर देखो मैं देखूंगा करंट की डायरेक्शन, तो ऐसे करके देखो करंट, एज्यूम करो कि ये ऐसे रखा हुआ है और एंटी क्लॉकवाइज डायरेक्शन में करंट हमारा फ्लो हो रहा है, तो थंब कहाँ जा रहा है, थंब जा रहा है मेरा इस डायरेक्शन में, एक्स डायरेक्शन में। तो इस वजह से जो मैग्नेटिक फील्ड की डायरेक्शन होगी, मैग्नेटिक फील्ड उसकी डायरेक्शन किस में हो जाएगी, आई कैप डायरेक्शन में, ओके। तो यहां से देखो डायरेक्शन मुझे मिल गई इस पूरे लूप की वजह से, ओके। तो पॉइंट P यहाँ पे है, तो यहाँ पे नेट जो मैग्नेटिक फील्ड होगा, नेट मैग्नेटिक फील्ड, नेट मैग्नेटिक फील्ड V इज इक्वल टू, V वेक्टर इज इक्वल टू क्या आ जाएगा यहाँ से हमारा, आई कैप प्लस के कैप, ओके, ये आ गया। अगर बात करनी है हमें यहाँ पे पॉइंट्स इन द डायरेक्शन भी बताना है, द मैग्नेटिक फील्ड ड्यू टू दिस लूप एट द पॉइंट ऑफ दिस एंड पॉइंट्स इन द डायरेक्शन, ओके, किस डायरेक्शन में होंगे। तो वी वेक्टर की अगर मैं डायरेक्शन की बात करूंगा तो एन कैप इज इक्वल टू वी वेक्टर अपॉन में मॉड ऑफ वी, सो सिंपली यहाँ से देखो मॉड ऑफ वी फाइंड आउट करेंगे तो क्या आ जाएगा, मॉड ऑफ वी आ जाएगा यहाँ पे अंडर रूट में आई का कोफिशिएंट का स्क्वायर, मतलब कि 1 का स्क्वायर 1 प्लस के कोफिशिएंट का स्क्वायर करेंगे तो 1 आ जाएगा, तो अंडर रूट वी मैग्नीट्यूड ऑफ बी सॉरी इज इक्वल टू में कितना आ जाएगा, अंडर रूट 2। तो यहाँ पे डायरेक्शन की अगर बात करेंगे सो एन कैप इज इक्वल टू वी वेक्टर है यहाँ पे हमारा आई कैप प्लस के कैप और अपॉन में रूट 2, ओके। तो सिंपली यहाँ पे मैं इसको लिख सकता हूँ 1 बाई अंडर रूट 2 और आई कैप प्लस के कैप, ओके। तो यहाँ पे हमें पी पॉइंट पे मैग्नेटिक फील्ड फाइंड आउट करना था, तो वो आ जाता है यहाँ पे मेरा कितना 1 बाई अंडर रूट 2 आई कैप प्लस के कैप, ओके। सो दिस इज द आंसर। अभी देखते हैं अपना ऑप्शन, तो ऑप्शन देखो यहाँ पे हमारा जो फोर्थ ऑप्शन है 1 बाई रूट 2 आई कैप प्लस के कैप is correct for this question. I hope you like this video and thank you so much for watching.
Hello everyone, so we are given with the question which says two long parallel wire are at a distance of 2D apart. They carry steady equal current flowing out of the plane of the paper as shown. The variation of the magnetic field B along the line XX is given by. So we need to check what will be the variation and how does it look. So let's begin. So we are given with two wires. Let's suppose that these are the two wires, and the separation between the two is been given as 2D. So let's make it over here as, so separation has been given as 2D, and let's suppose a point in general I'm supposing, which is at a distance of x from left wire. So from right, the distance would be nothing but 2D minus x. So the magnetic field at this point P, so we can write magnetic field due to magnetic field at point P due to left wire, due to left wire. So it can be written as mu 0 I by, since the wire is very long, so for infinite length wire, mu 0 I by 2 pi, r is the distance of the point P from the wire 1, let's say left wire, or we can say it as wire 1, and this is as wire 2. So distance will be x, and the direction will be, we can calculate it by using right hand thumb rule. So as the current is coming out, so thumb will point in the direction of current, so the finger curling will give the direction of magnetic field. Alright, so at P the magnetic field direction is above, that is J cap. Alright, similarly we can calculate the magnetic field at point P due to right wire. So we can see it over here as, it can be written as mu 0 I, since the both the wire is carrying equal current, so we can write it as 2 pi. Instead of x, the distance will be 2D minus x. Alright, so, and this the direction will be in the downward, so sense, so minus of J cap. So the net electric field at point P can be written as B net at point P can be given as B due to left, or we can let's suppose it as to be B1, and let's suppose it as to be B2 to avoid, just to avoid the confusion. So we can write it as B1 bar plus of B2 bar. Alright, so adding this value we will get the answer as mu 0 I by 2 pi can be taken out as common, so we are left with 1 over x minus of 1 by 2D minus x. Alright, so in general, if and here it is J cap. So this is the general magnetic field at point P, general equation for magnetic field at point P we have deduced. So let's say this is our equation number 1. So from this we can conclude if x is equals to D, if x becomes equals to D, so we can say the magnetic field, that is net magnetic field, will be 0. Alright, and if x is greater than D, then we can say the net magnetic field will be, so whole of the answer comes out to be negative, and the net magnetic field will be along negative of J, that is negative y-axis. And if x is less than D, so we can see that the net magnetic field on point P will be along the positive J-axis. So using this three result, we will check the options. So for first option, let's check. As we have seen, at x equals to D, the magnetic field value is 0. So at this point, the magnetic field value is 0, and it is true. And for the value that is x less than D, we can see for x less than D, the value of magnetic field is along the positive y-axis. So as we can see it over here, yes, it is along positive y-axis, and for x greater than D, it is along the negative x-axis. Yes, so the middle part of the diagram is correct. Now let's check the left part. So the left part of the wire, as we can see, the current is coming outward, so the direction of the magnetic field on the left part should be along the negative x-axis, but negative y-axis, but it is showing in the positive direction of y-axis. So this option is incorrect. So option A is not correct, and option C, as we can see, the middle part of the section is incorrect, so this option is also not correct. Option D is also incorrect. Now let's check option B. As we can see, as we have discussed, the middle part of the section is correct. Now let's check about the left hand side of the wire one. So as we can see, we can see over here, the as the current is coming outward, so the magnetic field direction is along minus j cap, that is along negative y-axis. So yes, it is along negative y-axis. And for wire 2, as we have seen that the current is coming outward, so the magnetic field direction on the right side will be upward, and it is shown in the upward y-axis, along upward y-axis. All right, so this option is the correct answer to this question. So I hope you have understood the concept, and thank you for watching.
इस क्वेश्चन में दिया गया है कि एन इन्फिनेटली लॉन्ग कंडक्टर पी क्यू आर इज बेंड टू फॉर्म अ राइट एंगल। ओके, इस क्वेश्चन में दिया गया है कि कोई कंडक्टर है पी क्यू आर, उसको बेंड करके क्या कर रहे हैं, राइट एंगल फॉर्म कर रहे हैं एज शोन इन फिगर। ओके, फिगर में हम देख सकते हैं एक करंट आई फ्लोज थ्रू पी क्यू आर, एक करंट फ्लो करिए पी क्यू आर से आई। द मैग्नेटिक फील्ड ड्यू टू दिस करंट एट द पॉइंट एम इज एच वन। एम पॉइंट पे इस मैग्नेट जो ये करंट कैरिंग वायर है, इसकी वजह से जो फील्ड है वो क्या है, एच वन है। अब कह रहा है कि एक अनदर लॉन्ग स्ट्रेट कंडक्टर ले रहे हैं जो क्या है, क्यू एस है। क्यू एस इज कनेक्टेड एट क्यू, सो दैट करंट आई बाई टू इन क्यू आर एज वेल एज क्यू एस। तो कह रहा है कि जब करंट को हम क्या कर रहे हैं, उसके सॉरी वायर क्यू एस को ऐड कर दे रहे हैं, तो आई बाई टू करंट क्यू एस से भी फ्लो कर रही है और आई बाई टू करंट क्यू आर से फ्लो कर रही है। ओके, तो हमें बताना है कि द मैग्नेटिक फील्ड एट एम टू इज एच टू। ये फिर मैग्नेटिक फील्ड चेंज होके क्या हो जा रहा है, एच टू हो जा रहा है। तो हमें बताना है कि एच वन अपॉन एच टू की रेशियो क्या होगी। ओके, ये जो वैल्यू हमारे पे दी गई है एच वन अपॉन एच टू, इसका रेशियो क्या होगा, यही हमें क्या करना है, फाइंड करना है। तो सबसे पहले हम क्या लेते हैं, केस फर्स्ट लेते हैं। ओके, केस फर्स्ट में हम ये देखेंगे कि ये जो वायर है पी क्यू, तो इसकी वजह से एम पॉइंट पे क्या होगा। ओके, तो केस फर्स्ट, ओके, केस फर्स्ट में हम लिखेंगे मैग्नेटिक फील्ड ड्यू टू वायर पी क्यू एंड क्यू आर। ओके, ये वैल्यू, तो जो हाफ सेगमेंट है उसकी वजह से जो मैग्नेटिक फील्ड आएगा एट पॉइंट एच वन जो आएगा वो क्या आएगा, 1/2, और स्ट्रेट वायर की वजह से क्या होता है, म्यू नॉट आई अपॉन टू, सॉरी ये क्या होता है, 2 पाई आर होता है। ओके, ये वैल्यू होती है। और प्लस जो ये सेक्शन है ये तो क्या है, इस एंगल के 0 डिग्री एंगल बना रहा है इस लाइन से, तो इसके लिए मैग्नेटिक फील्ड जो हो जाएगा वो क्या हो जाएगा, 0 हो जाएगा। तो एच वन की जो टोटल वैल्यू आ जाएगी ये क्या आ जाएगी, म्यू नॉट आई अपॉन 4 पाई आर आ जाएगा। अब जब क्यू एस ऐड कर दे रहे हैं तो हम उसको क्या ले लेते हैं, केस टू। केस टू, व्हेन क्यू एस इज एडेड, जब क्यू एस को क्या कर रहे हैं, ऐड कर दे रहे हैं, तो क्यू एस को ऐड कर दे रहे हैं तो यहाँ पे क्या फील्ड हो जा रहा है, एस टू हो जा रहा है। तो इनिशियल पी क्यू से तो सेम जाएगा। ओके, ये क्या होगा, मैग्नेटिक फील्ड ड्यू टू, ये सम होगा सबका, यहाँ पे हम लिख लेते हैं कि मैग्नेटिक फील्ड ड्यू टू पी क्यू प्लस मैग्नेटिक फील्ड ड्यू टू क्यू एस प्लस मैग्नेटिक फील्ड ड्यू टू क्यू आर। ओके, ये वैल्यू होती है। तो ये हमारे पास क्या हो गई, वैल्यू हो गई। तो अब यहाँ से हम क्या करते हैं, एच टू इक्वल्स टू, उसकी वैल्यू तो क्या आएगी, सेम आएगी, म्यू नॉट आई अपॉन 4 पाई आर प्लस जो क्यू एस होगा, उस क्यू आर की वजह से क्या होगा, 0 होगा, और क्यू एस की वजह से होगा म्यू नॉट आई अपॉन 2, और ये कितना हो जाएगा, ये आ जाएगा हमारे पास, अपॉन में कितना आएगा, अपॉन में ये वैल्यू आ जाएगी, ये आ जाएगा 1/2 आएगा, उसका हाफ है 1/2 2πr प्लस 0। तो ये कितना आ जाएगा, H2 की जो वैल्यू आ जाएगी म्यू नॉट आई अपॉन 4πr प्लस म्यू नॉट आई अपॉन 8πr। अब इसको ऐड कर देंगे तो H2 की जो वैल्यू होगी वो कितनी आ जाएगी, H2 आ जाएगा हमारे पास 3 म्यू नॉट आई अपॉन 8πr, ये वैल्यू आ जाएगी। ओके, तो ये हाफ हम इसलिए करें क्योंकि वो लेंथ की वजह से आ रहा है हमारे पास। क्या तो आपको एक फार्मूला पता होगा कि किसी वायर से किसी पॉइंट पे अगर हमें क्या करना होता है, मैग्नेटिक फील्ड कैलकुलेट करना होता है, तो हम क्या करते हैं, ये एंगल्स लेते हैं। ओके, ये हमारा θ1 होता है, ये होता है θ2, और इसके लिए फार्मूला क्या होता है, b इक्वल्स टू म्यू नॉट आई अपॉन 4πr साइन θ2 माइनस साइन θ1। ओके, एंगल्स के रोटेशन हमेशा याद होने चाहिए, θ1 हो गया और ये क्या हो गया, θ2 हो गया। ओके, तो अगर एंटी क्लॉकवाइज चलेगा तो माइनस थीटा लेंगे और क्लॉकवाइज चलेगा तो थीटा लेंगे। तो ये फार्मूला होता है, उससे 1/2 की वैल्यू आ रही है। तो अब हमें फाइनली पूछा क्या है, H1 अपॉन H2। तो यहाँ पे हम लिख सकते हैं नाउ H1 अपॉन H2। तो H1 क्या आया है हमारे पास, H1 आया है म्यू नॉट अपॉन 4πr, म्यू नॉट आई अपॉन 4πr अपॉन 3 म्यू नॉट आई अपॉन 8πr। तो ये वैल्यू क्या आ जाएगी, 4 से 8 कैंसिल हो जाएगा 2 टाइम्स में, ओवरऑल ये वैल्यू आ जाएगी 2/3। तो अगर हम अपने ऑप्शंस में देखें तो सी ऑप्शन इसे क्या कर रहा है, मैच कर रहा है। ओके, सो सी ऑप्शन इज राइट ऑप्शन। ओके, इस क्वेश्चन में दिया गया कि कोई बैटरी है जिसको कनेक्ट किया गया है 2 पॉइंट से ए और बी ऑन द सर्किमफेरेंस ऑफ अ यूनिफॉर्म कंडक्टिंग रिंग। कोई कंडक्टिंग रिंग है, उसके 2 पॉइंट से कनेक्ट किया गया, जिसकी रेडियस क्या है r एंड रेजिस्टेंस कैपिटल R है। वन ऑफ द आर्क ए बी ऑफ द रिंग सबटेंस एंगल थीटा। कोई आर्क ए बी क्या कर रही है, थीटा एंगल सबटेंड कर रही है। द वैल्यू ऑफ मैग्नेटिक इंडक्शन एट सेंटर ड्यू टू द करंट इन द रिंग। जो रिंग में करंट फ्लो करेंगे उनकी वजह से जो मैग्नेटिक इंडक्शन होगा सेंटर पे, उसकी वैल्यू क्या होगी, ये हमें क्या करना है, बताना है। ठीक है, तो सबसे पहले क्या करते हैं, इसको फिगर से समझने की कोशिश करते हैं कि कह क्या रहा है। तो एक सर्कुलर रिंग हमने बना लिया। ओके, ये हमारी क्या हो गई, सर्कुलर रिंग हो गई। ठीक है, अब इसके 2 पार्ट को हम क्या कर रहे हैं, रैंडमली, कोई भी उसने ये पर्टिकुलरली नहीं बोला है, तो 2 पार्ट हमने लिया और उसको बैटरी से कनेक्ट कर दिया। ठीक है, तो एक यहाँ से लिया हमने, ये हमारा हो गया, इसको क्या किया गया, बैटरी से कनेक्ट कर दिया गया। ठीक है, बैटरी की वोल्टेज क्या है, ई हमने मान लिया, और इसमें क्या फ्लो कर रही है, आई करंट फ्लो कर रही है। ठीक है, अब सेंटर से बोला है कि ये जो पॉइंट है, ये हमारा जो पॉइंट है ये हो गया। ठीक है, तो ये एंगल उसने बोल रखा है कि ये थीटा है। ठीक है, ये ए हो गया, ये कौन सा पॉइंट हो गया, बी पॉइंट हो गया। ये एंगल कितना है, थीटा है, तो ये कितना हो जाएगा, 2π माइनस थीटा हो जाएगा। और दोनों डायरेक्शन में करंट फ्लो करेंगी, इधर I2 करंट और इधर क्या होगी, I1 करंट। ठीक है, ये हो गया। तो अब ये जो इस साइड वाला आर्क है, तो अब इसको हम कुछ नाम दे देते हैं। इधर वाले पॉइंट को मैं C पॉइंट दे देता हूँ, इधर D पॉइंट दे देता हूँ। ओके, तो यहाँ पे मैं लिख सकता हूँ मैग्नेटिक फील्ड ड्यू टू आर्क ACB। ओके, ACB नॉट ACD, ACB। तो ACB आर्क की वजह से, ACB आर्क की वजह से यहाँ पे हमारा जो मतलब वैल्यू आएगा मैग्नेटिक फील्ड का, वो क्या आ जाएगा, उसकी वैल्यू आ जाएगी हमारे पास B1 मान लेते हैं, B इक्वल्स टू म्यू नॉट आई अपॉन 4πr इंटू थीटा, ये वैल्यू होती है। ठीक है, और ये किस डायरेक्शन में आएगा, अपवर्ड डायरेक्शन में आएगा। ठीक है, अपवर्ड डायरेक्शन में आएगा। अब क्या करते हैं, जो दूसरा हमारा सेक्शन है आर्क ए डी बी है, इसकी वजह से कैलकुलेट करते हैं। ओके, तो यहाँ पे हम लिख सकते हैं मैग्नेटिक फील्ड ड्यू टू आर्क ए डी बी। ये जो आर्क ए डी बी है, इसकी वजह से जो मैग्नेटिक फील्ड है उसको हमने मान लिया कि ये क्या हो गया, V2 म्यू नॉट आई अपॉन 4 पाई आर, और यहाँ एंगल क्या हो जाएगा, सॉरी यहाँ I1 होगा और यहाँ क्या होगा I2 होगा, और यहाँ एंगल होगा 2 पाई माइनस थीटा। ये वैल्यू हो गई, ठीक है। और ये क्या होगा, किस डायरेक्शन में, डाउनवर्ड डायरेक्शन में, डाउनवर्ड डायरेक्शन में होगा, ठीक है। अब नेट जो मैग्नेटिक फील्ड आएगा, बी जो नेट आएगा वो क्या होगा, ये होगा B1 माइनस B2 होगा। ओके, तो B1 माइनस B2 आएगा हमारे पास नेट। तो इसको हम क्या लिख सकते हैं, इसको हम लिख सकते हैं यहाँ पे, तो B1 की जो वैल्यू है हमारे पास कितनी है, म्यू नॉट I1 थीटा अपॉन 4 पाई आर माइनस म्यू नॉट I2 2 पाई माइनस थीटा अपॉन 4 पाई आर। ओके, अब यहाँ पे जो I1 है और I2 की वैल्यू उनको भी हम ज़रा देख लेते हैं। तो I1 क्या होगा, ये E अपॉन आर होगा। ओके, और रेजिस्टेंस जो है हमारा टोटल रिंग का दिया हुआ है कि ये टोटल कितना है, कैपिटल आर है। ओके, बट यहाँ पे हमने उसको चेंज कर दिया है तो ये से R1 हो जाएगा। और अब फिर क्या कर सकते हैं, E अपॉन आर को मैं क्या लिख सकता हूँ, डेंसिटी इंटू लेंथ अपॉन में क्या हो जाएगा, एरिया। ओके, ये हो जाएगा। अब यहाँ से हम चाहें तो ये एरिया ऊपर चला जाएगा, E अपॉन में रो L1 इंटू ए, और लेंथ क्या होगा हमारा, आर्क लेंथ हमारा ये आर्क हो गया, आर की लेंथ है, और आर की लेंथ को हम क्या लिख सकते हैं, थीटा इंटू रेडियस। ओके, एंगल इंटू रेडियस लिख सकते हैं। तो I1 की जो वैल्यू होगी ये क्या हो जाएगी, ई ए अपॉन, इसको लिख सकते हैं रो आर थीटा। सिमिलरली हम क्या करेंगे, I2 की भी वैल्यू लिखेंगे। I2 की वैल्यू अगर इसी तरह लिखा जाए सिमिलरली, तो इसको क्या लिख सकते हैं, ई ए रो आर, ये क्या लिख सकते हैं इसको, ये 2 पाई माइनस थीटा हो जाएगा। अब ये I1 और I2 की जो वैल्यू है इसको अपने फॉर्मूले में पुट कर देते हैं। तो B इक्वल्स टू म्यू नॉट थीटा अपॉन 4 पाई आर, और I1 की वैल्यू क्या है हमारे पास, ई ए अपॉन रो आर थीटा माइनस म्यू नॉट, ये कितना आ जाएगा, 2 पाई माइनस थीटा अपॉन 4 पाई आर, मल्टीप्लाई में क्या आ जाएगा, यहाँ मल्टीप्लाई में आ जाएगा हमारे पास, ये कितना आ जाएगा हमारे पास, I2 की वैल्यू कितनी आई हमारे पास, ई ए अपॉन रो आर अपॉन 2 पाई माइनस थीटा आ जाएगा। ओके, ये वैल्यू आ जाएगी। तो अब यहाँ से हम देख सकते हैं कि हमारे पास क्या आएगा, सारी वैल्यूज़ क्या हो रही हैं, कैंसिल हो जा रही हैं। बच क्या रहा है, B इक्वल्स टू म्यू नॉट अपॉन 4 पाई मैंने कॉमन ले लिया, ई ए अपॉन थीटा से थीटा कैंसिल हो जाएगा, रो आर स्क्वायर माइनस यहाँ क्या आएगा, 2 पाई से 2 पाई ई ए अपॉन रो आर स्क्वायर। ओके, तो B की वैल्यू क्या आ गई, 0 आ गई। तो कोई भी एंगल लिया जाए, यहाँ पे कोई भी अगर आप एंगल लेंगे तो ये वैल्यू क्या आएगी, 0 आएगी। तो यहाँ से हम अपने ऑप्शंस में मैच कर लेते हैं। तो डी ऑप्शन क्या हो रहा है, इससे मैच हो रहा है। कोई भी वैल्यू आप थीटा हम पुट कर दें तो उसके लिए क्या आएगा, हमारा आंसर 0 ही आएगा। तो डी इज राइट ऑप्शन। ओके,
Hello everyone. A current I flows along the length of an infinitely long, straight, thin-walled pipe. Then, the magnetic field at all points inside the pipe is same but not zero. The magnetic field at any point inside the pipe is zero. The magnetic field is zero only on the axis of the pipe, and magnetic field is different at different points inside the pipe. So the question is asking us that what is the value of magnetic field inside the pipe which is infinitely long, straight and thin walled and has a current I flowing through it. Using the Ampere's circuital law, which is given by integral B dot dl is equals to mu naught I. We know that over a circular loop of any radius less than the radius of pipe. Let us consider a cross section of the pipe. This is the cross section of the pipe. There is a current flowing through it which has a value I. At any radius which is smaller than this pipe, for example, something like this, we can see that net current inside this loop is 0. Therefore, the value of B dot dl integral will come out to be 0, and this implies that B is equals to 0 at any point inside the loop. Therefore, answer is option number 2, that magnetic field at any point inside the pipe is 0. Thank you.
The given question is a steady current I flows along an infinitely long hollow cylindrical conductor of radius capital R. This cylinder is placed coaxially inside an infinite solenoid of radius 2R. The solenoid has n turns per unit length and carries a steady current capital I. Consider a point P at a distance small r from the common axis. The correct statements are, so these are the statements, okay, 4 statements here given. Statement A, B, C and D, and we have to check which of the statements are the correct. So let me first give you a brief about the magnetic field. Okay, and see, in all the 4 statements we have to check the magnetic fields. Okay, so let me give you a brief about the magnetic field created by a hollow cylindrical conductor and a solenoid. Okay, so first of all, let's say we have a hollow conductor like this, okay, in which a current is flowing, okay, and current always flows through the circumference. Okay, let's say I current is flowing, okay, through this hollow conductor. So let this be the axis of the conductor. Now if I take a loop, okay, if I take a loop inside this conductor, then according to the Ampere's circuital law, then according to the Ampere's circuital law, in this loop, if I take the line integral of the magnetic field, then it will come out to be equal to mu naught times the current passing through this loop. So current passing through this loop will be 0, hence magnetic field setup would be 0. And if I take a loop outside this conductor at a distance small r, okay, then according to the Ampere circuital law, it will be B dot dl, and this will be equal to mu naught times I. And from here, after doing the calculations, we can see that the magnetic field at this distance r, we can find equals to mu naught I divided by 2r. Okay, so, and for the direction we have to use right hand thumb rule. Okay, so we have to place the thumb in the direction of current, and the curl of finger will give the direction of magnetic field. So if we place thumb in the direction from left to right, then this will be the polarity of the magnetic field. Okay, dot from the above and cross from the below. So this is about the hollow cylinder. Next we have is a solenoid. Okay, so for a solenoid, basically we have, let's say this is a solenoid. Okay, this is a solenoid on which the wire is wound. Okay, the wire is wound like this, and we know that for a solenoid, let's say I current is flowing inside the solenoid wires. Okay, so we know that the magnetic field generally confined within the solenoid like this. Okay, and we can find the direction of this magnetic field by the right hand thumb rule, and it will be along this direction.
Okay, so this will be the magnetic field, and magnetic field outside the solenoid is always 0. Okay, magnetic field inside only, magnetic field stays confined within the solenoid only. Okay, and it is given as B equals to mu naught times Ni. Okay, where I is the current flowing through the solenoid wire, N is the number of turns per unit length, and mu naught is the magnetic permeability of free space. So now let us check the statements one by one. So we are having in the region 0 to R, then less than capital R, the magnetic field is non-zero. Okay, so let me draw the figure for this and also. So we are having a solenoid. Okay, we are having a solenoid like this, inside which a hollow cylinder is placed. Okay, inside which a hollow cylinder is placed. Let me make it with other ink. So this is the hollow cylinder which is placed inside the solenoid with a common axis. Okay, so this is the common axis, and they are both infinitely long. Okay, they both are infinitely long, the solenoid as well as the hollow cylinder. Okay, so let me wound the wire. Okay, so like this wire is being wound on the solenoid. So I'm taking just few turns just to show the magnetic field. Okay, I current is flowing in the solenoid as well as I current is flowing in the hollow cylindrical conductor. So now we are given R, capital R is the radius of the hollow cylinder and 2R is the radius of the solenoid. Okay, so now in the statement 1 we are given in the region 0 to R less than capital R, the magnetic field is non-zero. So let us check this. So it is saying about this region. Okay, let's say we have a point between R. Okay, for statement A we are having a point between 0 to capital R, the magnetic field is non-zero. Now see, inside the, due to the hollow conductor inside this portion, the magnetic field due to this hollow conductor will be 0, but due to the solenoid there will be magnetic field present, because all the magnetic field due to solenoid will be confined within the solenoid only. Hence the magnetic field inside this region 0 to R to capital R will be non-zero, due to solenoid. Okay, due to solenoid, right? So the given statement 1 is correct. In statement B we are having in the region R from small r, capital R to R, the magnetic field is along the common axis. Okay, now see, in for this part we are having here, this is the point. So here we can see that due to this hollow conductor at this point. Okay, let me show this point here. So let's say this point is P. Okay, so due to the hollow conductor, the magnetic field at this point would be dot polarity. It will be coming out of the plane or the screen, and due to the solenoid it would be along right direction, right? So we can say that the magnetic field will not be along the common axis, because their resultant field would be somewhat cross magnetizing. Okay, and it will be not along the common axis. Hence the given statement B is false. In statement C we have in the region R less than 2 capital R, the magnetic field is tangential to the circle of radius R centered on the axis. Now see what is tangential. This is the part tangential. If I have taken only hollow cylindrical conductor, then this dot and cross is representing the tangential magnetic field. But in at the B point we can see that the magnetic field will be somewhat cross. This will be the B net magnetic field will be cross magnetizing. Hence it will be, we cannot say that this will be purely tangential to the circumference or the circle. Hence statement C is also incorrect. In statement D uh, we have the statement in the region R less than 2R, the magnetic field will be non-zero. So see, in this portion outside, okay, let me take this point P outside the solenoid. So due to solenoid at this point the magnetic field would be zero, but as I already mentioned that due to the hollow conductor there will be some magnetic field present at point P. So for statement D we have, for a region R greater than 2R, the magnetic field will be non-zero due to hollow cylindrical conductor. Okay, hollow cylindrical conductor. Thus, the given statement D is also correct. Okay, given statement D is also correct. So, from the given four statements, statements A and D are the correct statements. Thank you.
Hello everyone. Let us start with our question. In this question, what is given? A cylindrical cavity of diameter A exists inside a cylinder of a diameter 2A as shown in the figure. So this is the this diameter is 2A and here there is a cavity, this cylindrical cavity of diameter A. Now both the cylinder and the cavity are of infinitely long. So these are infinitely long. A uniform current density J flow through the length. Now if the magnitude of the magnetic field at point P is given as to be n by 12 mu naught AJ, we need to find the value of n. Okay. Now how can we do this? So for example, we can just replace this. We can say that this is our this whole cylinder, and let's say this is our cavity. So the net effect, if we need to find what is the net effect, what we should do, we should just say that here the current which is flowing is having a, we can just say that this is we just say that current density, if here is J, so here it would be minus J. We can just put this value. Okay. Now, and this would be equivalent to this part. So due to this, let's say corresponding to this, current here is I and current here is I dash. Okay. So due to a long wire, what is the value of the this magnetic field at any point? So we need to find the magnetic field at this point at P. So we can say that its value would be equals to mu naught I divided by 2 pi. What is the distance from the center from here to here? It is equals to A. Then here the current density is negative, so magnetic field would be subtracted. So minus mu naught I dash divided by 2 pi. Now what would be the distance of this center to this part? So it would be A plus A by 2. That means 3A by 2 into 3A divided by 2. We can put it like this. Okay. Now, what we can write this as? Now I dash and I, what are the values in terms of current density? We say that I value would be equals to current density multiplied by area, because this current is current density multiplied by area. So here value would be equals to pi A square, and I dash value would be equals to current density, which is J, and what would be the area? Here radius is here radius would be A by 2. Okay, diameter is A, so radius would be A by 2. So area would be pi A square by 4. So here the area would be pi A square divided by 4. Now this is the magnetic field, net magnetic field, which we have written. Now if we substitute these values, and what we can take mu naught divided by 2 pi into A to be common. So our B net would then turn out to be mu naught divided by 2 pi A. If we take this value to be common, then here it would be I, and here it would be I dash divided by 3. So I value we just substitute, it is pi J into pi A square, then minus, here the value would turn out to be this J into pi A square divided by 4 multiplied by 3. So this 2 and this 2 would be cancelled. Now if we solve this, so our B net would then turn out to be mu naught J into pi into A square divided by 2 pi A. Okay, we can take these term to be common. We can take it to be outside. So there is a fact. So the factor here we have taken it to be common. So 2 pi we have already taken it to be common. So here this 2 we have, because we have taken 2 pi to be common, so we can take it to be common, and then 2 would be remaining here. So 2 would be remaining here. Okay, then here what will happen? So it would be 1 minus 1 divided by 6. It would be 1 minus 1 by 6. That means 5 by 6. So we can just write our B net would be then equals to mu naught J into this A divided by 6 into 2. That means 12. Then multiplied by 5. Okay. Now if we compare this, what is the here it is given n divided by 12 mu naught AJ. So if we compare this, so it would be n mu naught JA divided by 12. So from here, these value would be cancelled. So n value would turn out to be 5. So what is the correct answer? Correct answer for n would be equals to 5. Hope you have understood the solution. Thank you. Hello everyone. Let us start with our question. In this question, what is given? That it is given that two parallel wires in the plane of the paper are at a distance x naught apart. Now a point charge is moving with a speed u between the wire in the same plane at a distance x1 from one of the wire. So first of all, we just represent this with a situation. So this is one of the wire and this is another wire. So basically these are the parallel wires. Okay, and there is a charge which is moving between these two. So let's say this is moving like this, and let's assume that this distance is, let's say this is x1 and total distance is given as to be x naught. So this distance would be x naught minus x1. Okay, now else what is given? When the current, when wire carries the current of magnitude I in the same direction, radius of curvature is given as to be r1. Now if the current direction in the two wire are different, that means opposite, so radius of curvature is r2. If x naught by x1 is given as to be 3, we need to find the value of r1 by r2. Okay, so in one situation, so the current is in the same direction, and in the other situation current is in the other direction. Now what is happening? So they are moving in a this circular path. Okay, and the radius of curvature is given as to be r. So in a magnetic field, what is the radius of curvature for a charged particle? R value is equals to mv by, this value is equals to mv divided by qb. This is the value. So from here, what we can see that because the value of the magnet, this velocity would be same, m and q are already same for the charged particle. So we can say that r is inversely proportional to b. Okay, or we can say that our r2 by r1 or r1 by r2, this would be equals to what? So because this is the inverse relation, so it would be b1 by, b2 by b1. Okay, b2. Now in the b2, what is happening, that direction of the current is opposite. Okay, here the direction of current is like this, here the direction of current is like this. So what will happen into this situation? The magnetic field would be b2 would be equals to magnetic field due to left plus magnetic field due to right. Okay, the direction of the magnetic field would be the same. Okay, when the direction of the current is opposite. So for example, here it is upward, here it is downward, so magnetic field would be downward into the plane of the paper. Okay, so what would be the value? So we know that value for magnetic field is given as to be, for a straight current carrying conductor, its value is given as to be mu naught divided by 2 pi, mu naught I divided by 2 pi, and the distance for left is this x1. So we write the distance as x1 plus mu naught I by 2 pi. From the right, it is x naught minus x1. So this is the value of b2. Similarly, b1 value would be what? So in the b1 case, the direction of current is same. So this would be the difference. So we just take the difference because the magnetic field would be in the opposite direction. So 2 pi x1 minus mu naught I divided by 2 pi x naught minus x1. Now if we take the ratios of these two quantity r1 by r2, it would be equals to b2 by b1. So we can take the ratio. So what we can see that mu naught I divided by 2 pi. So we can take it to be common, and when we are taking the ratio, so this term, constant term, would be cancelled. So we can just write our r1 by r2 as r1 divided by r2 would be just what? It would be equals to 1 over x1 plus 1 over x naught minus x1, this term, and then divide by, sorry, we just rewrite this division sign, divided by 1 by x1 minus 1 divided by x naught minus of x1. Okay, now in the numerator, if we take the LCM, so what will happen? So it would be x naught minus x1 plus x1. Okay, like this. Now the LCM of the numerator and the denominator would be same, so we can cancel, and we can just write the numerator of the denominator. So it would be x naught minus x1. Okay, minus x1. So the LCM would be cancelled. So it would be x1, x naught minus x1. Here it would be x1, x naught minus x1. We can cancel these values. So then our r1 divided by r2, this would turn out to be, so here x1 and x1 would be cancelled. So it would be x naught over x naught minus 2 times x1. Now if we divide the numerator and denominator by x1, so what will happen? So it would be x naught by x1 divided by, here it would be x naught by x1 minus, when we divide this term, so x1 would be cancelled, so it would be just 2. Now this value has given as to be 3, so we can say that 3 divided by 3 minus 2. So R1 by R2 would turn out to be 3. So this is the final value. We need to find the ratio of R1 by R2. So R1 by R2 we just write. So this value is equals to 3. So hope you have understood this solution. Thank you.
Hi everyone, so we are given with a question which says a pair of stationary and infinitely long bent wire is placed in the XY plane as shown in the figure. The wire carries current of 10 ampere each as shown. The segment L and M are along the x-axis. The segment P and Q are parallel to y-axis such that the distance between OS and OR is given as 0.02 meter. We need to find the magnitude and direction of magnetic induction at origin O at this point. Alright, so here we can see in the diagram uh, there are two pair of bend wire that has been given, that is LP and MQ. So here we can see M and L are lying along the x-axis. So we can see a magnetic field due to section, or we can say due to wire L and M will not be taken, or we can say will not constitute to magnetic field. So here let's write it more properly over here. Constitute to magnetic induction at O. As we know, a magnetic field will be around the wire carrying current, alright, and not on the axis, we can say. So here we can see the wire M and L is lying along the point where we are interested in finding the magnetic induction. So L and M will not constitute for magnetic induction at O. Therefore, we can write net magnetic field at O can be written as, therefore we can say net magnetic field will be due to wire uh, P plus magnetic field due to wire Q. Alright, so let's try to calculate the magnetic field due to these two wires. So we know these are the semi-infinite wire, as we can see it over here. From S to here it is, we have to consider from S to infinity, and from here R to infinity. That is, in this case we can consider it to be a semi-infinite wire. So for semi-infinite wire we can directly use the results. So for P we can write first. For semi-infinite, result is mu naught I by 4 pi A. A is the distance here is OR. Alright, from the point where we are interested in finding, that is OR. So this is the magnitude of the magnetic field we are getting, and if we wish to find the direction, so for direction can be given by right hand thumb rule. Thumb should point in the direction of current, that is downward, and curling the finger around this, so finger that is it will come outside, the magnetic field direction will be outside, or we can say represent it with a dot. So this is how the magnetic field due to wire B we have calculated. Or if we simplify it further, so we can write mu naught by 4 pi can be taken as 10 raised to minus 7 into I is been given as 10, dividing it by OR. OR has been given as 0.02, and this comes out to be 10 raised to 5 into 10 raised to minus 5, and direction is outward. Alright, so this is what the magnetic field due to wire P we are getting. Similar way we will calculate it for BQ. As we can see, the wire is carrying the same current, and it is also semi-infinite in length, so we can write this can be written as I am directly writing the result over here. So this also will comes out to be 5 into 10 raised to minus 5, and the direction can be again calculated by using right hand thumb rule. So again it will be outward at point O. Alright, so from here we can say therefore BO, that is net magnetic field at O, can be written as BP, that is this can be written as 2 into 5 into 10 raised to minus 5 and it is outward. So this gives us the answer as 1 into 10 raised to minus 4 Tesla. So this is the unit of magnetic field. So we can say this is the answer to this question, that is net magnetic field or induction at O we are getting. So I hope you have understood the concept well, and thank you for watching. Hi everyone, so we are given with a question which says a pair of stationary and infinitely long bent wire is placed in the XY plane as shown in the figure. The wire carries current of 10 ampere each as shown. The segment L and M are along the x-axis. The segment P and Q are parallel to y-axis such that the distance between OS and OR is given as 0.02 meter. We need to find the magnitude and direction of magnetic induction at origin O at this point. Alright, so here we can see in the diagram uh, there are two pair of bend wire that has been given, that is LP and MQ. So here we can see M and L are lying along the x-axis. So we can see a magnetic field due to section, or we can say due to wire L and M will not be taken, or we can say will not constitute to magnetic field. So here let's write it more properly over here. Constitute to magnetic induction at O. As we know, a magnetic field will be around the wire carrying current, alright, and not on the axis we can say. So here we can see the wire M and L is lying along the point where we are interested in finding the magnetic induction. So L and M will not constitute for magnetic induction at O. Therefore we can write net magnetic field at O can be written as, therefore we can say net magnetic field will be due to wire uh, P plus magnetic field due to wire Q. Alright, so let's try to calculate the magnetic field due to these two wires. So we know these are the semi-infinite wire, as we can see it over here. From S to here it is, we have to consider from S to infinity, and from here R to infinity. That is, in this case we can consider it to be a semi-infinite wire. So for semi-infinite wire we can directly use the results. So for P we can write first. For semi-infinite, result is mu naught I by 4 pi A. A is the distance here is OR. Alright, from the point where we are interested in finding, that is OR. So this is the magnitude of the magnetic field we are getting, and if we wish to find the direction, so for direction can be given by right hand thumb rule. Thumb should point in the direction of current, that is downward, and curling the finger around this, so finger that is it will come outside, the magnetic field direction will be outside, or we can say represent it with a dot. So this is how the magnetic field due to wire B we have calculated. Or if we simplify it further, so we can write mu naught by 4 pi can be taken as 10 raised to minus 7 into I is been given as 10, dividing it by OR. OR has been given as 0.02, and this comes out to be 10 raised to 5 into 10 raised to minus 5, and direction is outward. Alright, so this is what the magnetic field due to wire P we are getting. Similar way we will calculate it for BQ. As we can see, the wire is carrying the same current, and it is also semi-infinite in length. So we can write this can be written as I am directly writing the result over here. So this also will comes out to a 5 into 10 raised to minus 5, and the direction can be again calculated by using right hand thumb rule. So again it will be outward at point O. Alright, so from here we can say therefore BO, that is net magnetic field at O, can be written as BP, that is this can be written as 2 into 5 into 10 raised to minus 5, and it is outward. So this gives us the answer as 1 into 10 raised to minus 4 Tesla. So this is the unit of magnetic field. So we can say this is the answer to this question, that is net magnetic field or induction at O we are getting. So I hope you have understood the concept well, and thank you for watching.